Hello, everybody, and welcome to another session with the Assembly. We're very happy to see you. Today, of course, we have a very special workshop where we have a guest presenting with us, and it's an old friend of the Assembly, Professor Judhi Prasetyo. He did a workshop a little bit earlier on, just after the COVID lockdown started, and he did show us how to build our own infrared thermometer, which is a very practical workshop and a very useful one. Professor Judhi this time will be taking us back a bit and showing us a more generalized version so that everyone who is interested in getting started with robotics and Arduino can learn on their own. I'm just going to have a quick check on my screen just to make sure everything is okay. Yeah, I think we're fine. Okay, before we get started, let me just say, I'm sure most of you have been to assembly sessions, and most of the time we would be doing these live. Until the COVID lockdown, we were doing all our sessions live, and every Saturday it was a habit. People would turn up at In5 and they would come and meet us, and we would be doing different topics each week. Since the lockdown, and since, of course, the continued, obviously we are still under this crisis, we are continuing to to broadcast our sessions online. And hopefully at some point we are expecting to get back to In5 and the comfort of our preferred space. But for the time being, we are going to continue doing things live. We're not going to go off the air. So please do check back every Saturday at the same time. So we are going to keep the habit going. Most of you would have attended our sessions earlier. I am just going to come over to, just give you guys a little bit of a brief on what the assembly does so that you can be clear on that. So we are a smart lab based out of In5. So when I say smart lab, we're a physical space based out of In5 where people work to build this content that we present, as well as do work on a lot of other things like prototyping and an assortment of things that are very useful. So as I mentioned, we do a workshop every week. So we do a workshop. If you do the math, then you can see that we do about 50 workshops in a year. And we've done over 250 free workshops, and all our workshops are completely free to attend. Nobody has to pay anything to gain knowledge at the assembly. We do it completely free of charge. Anyone can turn up. There are very free prerequisites. If there are prerequisites, we mention it quite clearly, but most of the time we'd like to have it in such a way that anyone who has an interest in technology can come and do stuff. Learn with us on that. So I mentioned we're based out of In5. In5, of course, is the startup hub for Dubai Internet City, and the assembly also functions as a prototyping lab out of In5. So we do work on a lot of, especially with smart technology, and we try to do practical applications. So we try to build things. So whether it's 3D printing, robotics, working with embedded systems, IoT, all of these, as well as, various software APIs and frameworks. There's so many options now. We do it all. So, but we have split our workshop, like a repertoire, into three. We have Assembly Hack, which would include today's workshop, where we work with embedded systems, robotics, and IoT and hardware. So things like the Raspberry Pi, the Arduinos, and other kinds of microcontrollers and devices. So we do show you how you can work with that. When we do our live sessions, you don't have to bring your own hardware. We provide all of that for the people who attend. And of course, when you are following along online, you might have to, you can follow along, of course, without the hardware, but if it's always better if you get your hands on some of the hardware that we recommend, and usually we tell you in advance. In this case, we will just need an Arduino and a few simple sensors, and Professor Judhi is definitely going to take you over that. We also have assembly code workshops, which are purely software-based. We work with a whole bunch of different frameworks. You would have seen React Native, React workshops, Node.js workshops. We work with mobile app development. We work with specific APIs that people might not be aware of, but which are useful for doing different things like the Google Maps APIs, other Maps APIs. We also have our latest stream is the Assembly Data Science. Assembly Data Science is related to all topics to do with AI and ML, as well as, of course, basic data science. It's a big umbrella term, but we try to do that for more sophisticated data scientists. So that is slightly more advanced content. We try to get guest speakers to speak about that. Our target audience is a wide range. We have students, we have professionals, we have entrepreneurs, And we usually get we get people of all ages, ranging from as young as 15 to as old as 70. There's no upper limit, of course, but anyone is welcome. Anyone who wants to learn something about technology is welcome there. You should check out our forum. That's where we post all our resources. That's members.theassembly.ae. You'll get all the information about our workshops as well as the follow-ups. So you'll see things like GitHub links and all of those posted there. So that is our way to do that. We're very active on social media. Obviously, since things are online, we do have to be more conscious of that. So you can find us on social media at a variety of places. Our mission statement is make smart things. So that is where you will find us. That's also our social media handles. You can find us on Facebook, Twitter, Instagram, and of course YouTube, where you're watching this. We have a very active site, and we do post our workshops to the site also, the online workshops. And of course, we're on LinkedIn also. So please feel free to connect with us, comment on our workshops, give us ideas, discuss about our things. We are very happy to talk with you. Now, before getting further, I'd like to do a proper introduction for Professor Judhi. I think he's going to just come on the mic as well. And I'm just going to share his screen in a little bit. I'm just trying to get all my Zoom settings in there. Let me get Professor Judhi. Now, before I get Professor Judhi onto the screen, I just want to tell you a little bit about him. Professor Judhi is, of course, we mentioned he's a lecturer at Middlesex University, but that's just one of the hats he wears. He's an entrepreneur also. He's somebody who I would consider has the best knowledge of embedded systems in the UAE. And, I think if you talk about robotics and embedded systems going hand in hand, he's one of the people that you would go to if you had to get any knowledge. And we definitely rely on him once in a while to do a workshop, because he's an old friend of the assembly right from the start, right when we were talking about December 2014 as a start. Apart from that, Middlesex University has also set up its own RoboTech lab, and Professor Judhi is spearheading that, and he's the one who is the in charge there. And Middlesex University you should definitely check out, because they have a number of opportunities for aspiring roboticians, if that's the correct word. So I'm just going to bring Professor Judhi onto the screen, and then you can. Hi, Professor Judhi. It's good to have you here. Can you hear me?
Yes, loud and clear. Good morning,
Nikhil.
We
can hear you also. It's loud and clear. No, we're very excited about today's session. It's the topic, as you've suggested, is robotics for all. So it's very exciting for us that we are going to do something that is available, that everyone can understand. The last time you did a session, sorry, I'm just fixing a few bugs on my screen. Excuse me. Sorry, I'm just having a little bit of a... There we go. It's very exciting for us that you're doing this, because, we are going back to basics a bit. I understand you're going to be using the Arduino in this. Is that the primary tool?
Yes, that's right. But before that, Nikhil, may I request one thing?
Sure.
You can just call me Judhi.
I know it's force of habit, because
I know it's a habit, it's difficult, but I think we are outside the classroom. It's robotics for all. So there's no professor here, there's no student here, there's no I probably know a few things that you have not known. Does not mean that I'm smarter than you or anyone else. So the spirit here is to share what I know, and you probably want to share what you know as well. So
of course, and absolutely, I will remember that. I'll call you Judhi. I'll accept the request, because though I know how learned you are, so definitely we'll do that. And I appreciate that, you taking the time to share this session. The last workshop we did with you, I think you saw the response. We're still racking up views on YouTube for that. I think it's got up to 13,000 since then. So people are very interested in what you have to share. And definitely, I think this will take it a step back to the people who had more elementary questions. We do have a live chat going on our website as well. So people are sending in questions. And obviously, you'll be focused on your system. But I will definitely make it a point once in a while to just pop in and maybe interrupt the flow a bit, but at the same time just ask you to clarify a few things. But by and large, I'll let you carry on with that. So, Professor Judy, I'm just going to hand over the screen to you, and then please
Judy.
take it away. Have a good one.
All right. Okay. Then you can, from there, you can have an idea. Yeah. All right. Okay. Yeah. So we make robot to help human, not to replace human. That's something that is really important because some people say, "Hey, Judy, you're doing a nasty thing." Why? Because you are teaching human to teach machine to replace human. No, no, that's not my intention. I teach human to teach machine to help human, not to replace. Well, in most cases, yeah, there are some cases that the human replaced by machine, but it's not machine who replaced the human, right? Okay, good. Thanks for the hints from the chat. I can read the chat also on YouTube. So if you have any question, let's make it interactive as possible. As interactive as possible, you can ask something. I might answer or I might not answer or I may delay my answer, but just write anything that you like over there. If my voice is not very clear or something, just give us feedback. All right. So the definition of robot in modern day, usually people refer to the Robot Institute of America, reprogrammable, multifunctional, manipulative design to move materials, parts, tools, and blah, blah, blah. It's too long. To me, it's just a computer programmable machine. Anything that you can program with computer, that is a robot. Okay, so it's very easy, simple. Robot doesn't have to always have arms and legs. Robot can be just having a microphone and speaker, just like your computer in front of you or your phone in front of you. That can be a robot also because you can program it. You don't believe me? Remember, if you're on iPhone, you can say, "Hi Siri," and then it will reply, right? So it is a robot. Or, "Okay Google," and then your phone will respond. Or Alexa will respond. Oops, sorry, my Alexa is popping up. No, not you. Okay. There are some applications of the robot today, mainly is in the industry, right? On the top left over here, we see the robot is, the robots are making some cars, doing welding that otherwise very dangerous and labor intensive. Should this done by humans, so the human can do something else that is safer and more meaningful. On the top right, there's a robot that cooks. Okay, it's not that smart actually, because what this robot does actually just repeating what a world-class chef has done. So The way we program this robot is by recording the movement of a chef cooking something and then replay that back with a mechanical arm. So the robot is not smart enough. Let's say you switch the salt and pepper bottle, it will know. It will just pick from the same location. Maybe next generation robot will be better. The bottom left is a robot used in the hospital or in the elderly or in the healthcare situation where, especially in this kind of time, there are many cases, hospital is overwhelmed, the healthcare worker are overwhelmed, we don't have many of them, so robot can come handy. Some of them are helping lifting heavy object like patients over here. Some of them helping to carry the medicine around. Some of them going around the hospital and offices spraying disinfectants. So they are really, really helpful when we have shortage of manpower. On the bottom right is a robot that is sent to Mars. Okay, it's Curiosity. It's autonomous robot because we simply cannot remote control them. It's just too far from us. If you use a joystick and try to drive it, you press left. 15 minutes later, it will turn left because the distance is so great. So the radio will travel more than 15 minutes just to reach them. So this robot has to be autonomous and take care of itself. Okay. All of those robots, they have the same principle. They work the same way, like this. Okay. All robots works this way. They have sensors, they have actuators, and they also have processor. Okay. So first, the robot will sense the environment using their sensors. The environment that is sensed can be temperature, can be position, can be distance, or light, or sound, or voice. Okay, so these are the example of sensors. We know there's a distance sensor, for example, that is at the back of the car or at the front of the car that sense the distance from the object next to it. So when you reverse your car, you don't hit the wall. There is also a light sensor that detects if there's a light, then it does something. For example, automatic window curtain. When it's morning, the sun is up, the curtain will open. Okay, it's also can be considered as a robot. It's a simple smart device, but it's a principle of robotics, right? So imagine you don't have a slave to monitor if the sun has been is up and then open the curtain, but you have a simple mechanism called robot to open the curtain when the sun is up. The processor will decide what to do based on the input of the sensor. So in the earlier example, if the light is up, okay, the sun is up, there's a light hitting the sensor. The sensor will send to the processor. The processor will say, okay, so it's time to open the curtain. And then it will send the signal to the actuator. In this case, it's a motor to open the curtain. All right, in your car, for example, if you reverse, when you are reversing, there is a distance sensor at the back of your car, that the sensor that will measure the distance and then send to the processor. The processor will decide based on the distance. If it's still far, then it gives an okay signal. Maybe it's just beep, beep. But as you are getting closer to the object behind you, the beep will getting faster. Beep, 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 beep. And if it's really close, it will just beep, indicating that you're very, very close to an object and you should stop. So all of this decision is made by the processor. It does task planning, process the data, path planning, and also motion planning. The actuators are the one that is giving the feedback to the environment. Can be a movement, right? Like the motor that opened the curtain, or sound or speech, like in the car reversing alarm example just now. It can be a speech, like your Google or your Siri will talk back to you. Can be a text, like the chatbot. When you open a conversation on the website, let's say, you want to go online shopping, and then there's a chatbot over there that you want to ask something. It's probably not a real person over there, but you see it as a real person because it responds. It responds with text that is corresponding to your question, but it's actually a robot. It's possible. Or visual feedback. A simple LED that blinks can be considered as an actuator as well, right? So when the LED blinks, it will indicate that the processor has done something. It can be also like a light, right? If there's certain conditions, if there is a person entering the environment, sensed by the sensor tell the processor, if somebody's here, the processor will tell the actuators, okay, turn on the light. That's an example. All right, moving forward now. What are we going to make today? We are going to make a robot that can unlock the key if correct code is entered. But wait a minute. Isn't this just a smart device? It's not really a robot, all right? Is it really a robot? Can you type something on YouTube or something? Oh, I have some delay, so probably I wouldn't see the answer right away. But yes, it is a robot. You can consider a robot if you go back to my definition just now, that robot is a computer programmable machine, then you can consider this as a robot. And yes, it's true enough because it needs some smartness in it. Okay, there is a component like input, and then it has to be checked, and then there's an output, which is the unlock. The input is code, the output is the door unlock. Yeah. So it's not really just a normal lock. Okay, it's a robotics lock. If you see again on the previous slide, the robot has to sense, process, and act. And this lock also have a sensor, have a processor, and have an actuator. So it's considered a robot, right? Okay. Anyway, as we go through, we will see that there are some robotics principles that we can apply over here. First, the input. Okay. The input is a code, right? A code that it has to be correct to open the door. Can you give me an example of what kind of input that usually you use to unlock the door? Yeah, you can type over here. Yeah. Okay, I have some other channel also. Okay, yes, RFID card. Okay, this is one example. You have seen this in many places. So you have an RFID card, you tap it on the reader, that's the input. Okay, the input will send to the processor, and then the door will be unlocked if this is the correct key. Okay, we have seen this also used in the parking gate, for example. Okay. And then what else? What do you usually need to open a door? Electronically, of course. Yeah, okay. Keypad. Yes, this is also a popular input device that you can use. You press the correct code, let's say 1, 2, 3, 4, the door will open. If you enter 7, 8, 9, 0, it won't open because the code is incorrect. Keyboard, yes. Voice, very good. I've seen some answers on YouTube channel. Yes, very good. So yeah, there's some voice activated lock that can recognize your voice. Also, there's a fingerprint. Yeah, you put your fingerprint. This is very common. Or camera, very good, very good. A camera is now commonly used to open the door. So the camera will capture your face. If it matches its database that previously stored your face over there, it will open. Yeah, I have a funny situation before that. I know someone who came back from a shopping mall. She just did a makeup on her face, and she couldn't enter the house because the door couldn't recognize her because of the makeup. Yeah. So yeah, this is one of the drawback. Yes, she's staring at me now. Okay, but what we are going to do right now, yeah, we are going to the actuator later on. Now we are going to take a look at the input first. Yeah, we are getting there. What we are going to do now is we are going to use a single button as an input, not an RFID, not a keypad, not a keyboard, not a camera, no fingerprint, no fancy stuff. A simple button, a push button, right? How is it possible? Well, let's take a look. Okay. After sense or after the input, what next? To check, right? There's a process there. There's a process. To process, it will take the input, in this case, the button press, and determine something, what to do. Okay, so there is a comparison. Like we have a secret code, it has to compare with that. What do you need over here? A computer, good. A computer like this? Yeah, you could, but it will be too expensive to use this kind of computer, right? The desktop computer, you could play game, you could play more meaningful stuff than just guarding the door. Okay, so we need a smaller computer like this, laptop. No, this is still too big. And laptop is now more expensive than desktop in some cases. So because it's portable, it's small, you can bring it around. So it's not really suitable for this job. So what kind of computer is suitable for this job? You could use your mobile phone. Yeah, maybe old mobile phone, but we still need to modify it because it doesn't have input output that can interact directly with the environment in this case. Yeah, it has camera. Yeah, it has a speaker, but if you want to make it to open the door, it needs something else. So what we are going to do, we are going to use over here in this case is an Arduino. Yeah, it's small there because I just put it in scale so you can see the form factor. It's very small for some of you who have not used Arduino before. It's really small as compared to a laptop or desktop or even a mobile phone. Okay, if I blow it up, it looks like this. Okay, it's based on the single processor that is a system on chip. Everything is there inside the chip. It's a 80 mega chip. And there are some ports over there. We're going to be to discuss this in more detail later on. Okay, some of you are already familiar. That's good. Some of you maybe this is the first time for you to see the Arduino. That's fine. This video will be available in recording, so you can always watch this again later. Okay, the actuator. Some of you have been asking, well, what are the actuators? Okay, there are many options for the actuators. You could buy those nice and expensive stuff, like the actuator, like on in the middle over here is usually actuator that's used to lock and unlock your car door. That's why it comes in a pack of 4. It works on 12 volt. Yeah, you could use this. There are some modification needed to your Arduino or some additional driver needed. Or you can use a door electric strike that is commonly found in offices, in shopping malls, right? That will keep the door shut and locked because of the magnetic force over here. Or you can buy an electric rim lock that can be fitted in a normal door like this. But as I promised, today we are going to build something out of a simple stuff that you can find even in the most common, the most basic Arduino stuff, which is a servo motor that costs less than 10 dirhams. Well, yeah, there are different types of servo motors. There are expensive one as well. Depends on the quality, right? You pay peanut, you got cheap one. So you can you can choose whichever type of servo motor that you like, whether the small one, the big one, the strong one, the expensive one, depends on your usage. But the principle is the same that I'm going to share with you today. Okay, so the motor itself, this is where the robotics principle comes into the picture. There are many ways to turn the key, right? So the key can be turned circularly, like if you do unlock and locking of your normal door. And there's a popular way of locking the door, which is using the latch. The latch is a linear. Motion, but the servo motor is a rotational motion. So in robotics, we know something called kinematics. Kinematics is a study of motion. So it studies how things move and how we can convert the movement. We have a rotational move of the motor, of the servo motor over here. But if we want a lateral move, or we want to have a linear move, we have to convert it. There are several ways of converting rotational move to linear movement. For example, there's a crank slider on the left hand. There's animations you can see. It looks familiar, right? But it is, some of you may not consider this before, but now you will look at things differently, because this is kinematics that is changing from rotational movement into linear movement. And then there's a rack and pinion. This is commonly found on in the automobile industry, in the car. The steering wheel is using rack and pinion most of the time. Okay, you can also build this to make a lock. And there's also a linear actuator that works like this. There is a motor that is turning a screw. The screw, there are some turns over there, right? So imagine if you have a nuts and bolt, and you keep the nuts and you turn the bolt will move linearly, right? Left and right, like this. So all of these are the principles that you can build yourself. Otherwise, of course, you can buy some ready-made stuff. Or you can just be creative. I found this picture on the internet. Somebody just put the servo motor directly to the latch on the door, like this. Yeah, it looks ugly, but it works. It works. Yeah. Or if you want to be more elegant a little bit, you can do a 3D printing like this. I will include the link over there where you can download the 3D file, and you can print it yourself, right? So put the servo on the 3D printed mechanism like this and put it on the door. Of course, not only it looks more elegant, but also it is more secure. It is better, stronger. Okay, if you have any question, please don't forget, you can always type your questions on the chat and we will answer you right away, or maybe I will answer you later. Now, we are going into the more exciting stuff. If we put them together, it will look like this. We have one button as a sensor. It will go to the Arduino Uno in this case. Of course, you can use any other Arduino, even any other board. It works the same principle. And then the Arduino will give the command to servo to open only when the correct code is entered. Right. We have only one button, but we are going to use it to enter the code. But how? To enter the code with only one button. Anyone can guess? Yeah, some people say, how that possible? It's one button, either you press it, it's open, or you don't press it, it's closed. No, there is a way. There is a way to enter a code with only one button and make the Arduino to open the door only when the correct code is entered. Anyone want to try? Type on the chat over there. Yeah.
Hi, Professor Judhi. I'm on your screen now.
Yeah.
I think
Okay.
I'll have a go with that. Are you just going to use one button? Is it just going to be a toggle?
A toggle. A toggle. Yeah, possible, but toggle means it's only open or closed.
Right.
Is that what you mean?
Yeah, as in, so the same button would be doing both. So it would just be.
Aha, okay. Yeah, good attempt, Nikhil. But we have a winner over here, Sumit Rajora. Sumit Rajora has put the right answer on the YouTube chat window. He said Morse. Very good. So I made this contraption inspired by Samuel Morse in 1841. Okay, he introduced the Morse code that consists of short and long press of the button. It is not a Morse code. I mean, this LockBot will not work based on the Morse code, but with the same principle, which is a short and long press of the button. Okay, this is how it works. In robotics, usually before we make stuff, we will make a state machine. A state machine is a representation of how the machine will behave at any given time. So there is a state. Yeah. Here we have a sample secret code, which is 001011. That represents short press for number 0 and long press for number 1. So for 001011, it should be short, short, long, short, long, long. Okay? So you press those sequence on the button, the Arduino Uno will determine whether it is correct or not. But we have to check it one by one. Okay? For example, the first state, we start with number 0, yeah? The state 0. If you press 0 over here, I hope you see my cursor. If you press 0, it will move to the next step, step 1. If you press 0. What if you press 1? Or it means that you do a long press. If you do a long press, it will go back to itself, means it will not advance. So you will stay in this state. Okay? You will stay in this state and you will never go to the next state. Now, if I enter a correct code over here, 0, now I'm in the state 1. It will check again what will be my next press. If I press short again, which is 0 over here, short press, I will be moved to the second, state 2, which is the third one over here. Now, after I reach here, I must press long because the third one over here is 1, means I have to press long, okay? But if I press it wrongly, I enter 0 instead of 1, I will go back to the first step again over here. Means I will never reach success, yeah? I will always go back to the beginning, yeah. There is a comment on YouTube. You have LED or any output that you could press to move across digit and release to select more user-friendly. Yes, but there is a reason why I don't put a visual feedback over here. This is to prevent something called brute force. Okay, imagine you put this on the door, on your main door, your house door. And then somebody see that, oh, the light is blinking every time you press. Oh, maybe there's something. Okay, since I got a feedback, I can always try the sequence, right? It's difficult, it's hard. But if you're going to your home country for 3 months, I have plenty of time, right? So it's good to not to have feedback. Since you know anyway, lock doesn't have to be user-friendly. It is user-friendly, but to us, to ourselves, the creator of this lock, it doesn't have to be user-friendly for anyone else. Yeah. So you might ask, what if I do wrong? How do I know whether I enter correct or not? It's simple. If the door is not unlocking, means your code is wrong, right? Then you may ask, how do I know in which state I am? Well, to know in which state you are is just you can just press the button several times. You will be in go back to the first state. Okay, so don't worry about that. You will, if you enter wrong, you're always on the first state on here, state 0. I lost my cursor. Let's see. Not sure why I lost my cursor. Yeah, but it's there. You will be on the state 0 if you're wrong. So you can purposely press any key and you will always go back to the state 0. Okay. Okay, I got my cursor back. If you enter that correctly, keep on entering the correct code, you will ultimately reach the success. Okay. Yes, of course, you can always put additional things like a feedback over there if you like. But I don't like to put feedback because I don't want to make it user-friendly for people other than me or people whom I give knowledge on this.
Professor Judhi, I'm back on your screen.
Sure.
Just had a quick question from, just to elaborate on Eliseo point, and I think you just replied to it also. How would you achieve the scheme without visual feedback by memory? So I think, yeah, sorry, you were just addressing that. So he's asked, can you see the comments? It says...
Yeah, I can see the comment. Okay, I'll go back to this slide. Yeah, I can see the comment. So I was addressing that just now.
Okay.
The visual feedback actually can go against you because it gives a clue whether you are correct or incorrectly enter the code. The only feedback you want is that you hear the motor turn, kick, okay, the door is unlocked, or you just push the door. That's the only feedback you want. Of course, you can put later on in the code a feedback, visual feedback. Every time you enter a right code, then it will give a green. If it's wrong, it will give red. But it will defeat the purpose of secret, right? Because then people can just try that one by one. And how secure it is? How secure it is, it depends. In this case, is 6 digits. So 6 is 2 powered by 6 is 64 combination that we can achieve. Of course, 64 is very easy to try 64 times. But first of all, the intruder doesn't know how many digits exactly our key has because this can go up to as many digits as you like. Okay, I have personally tried this with 10 digit, which means you will need to try 1024 combinations. Okay, of course, there's a chance maybe halfway you will be successful, but it can go that many. 11 digit will be 2048. 12 digit will be 4096, and so on. You just add one more digit and the probability will double.
Yeah, I'm sure we can, the amount of complexity, of course, depends on how much security you want with that. This is, I guess, a proof of concept.
Exactly.
And then, we can always expand on that. Great. Guys, I just wanted to remind everyone, please do keep your questions coming in. There is a slight delay between what Professor Judhi is presenting, so you might not get an instant response, or you might be Professor Judhi Judhi might not get an instant response. I have to get used to that habit, but we will try to keep it going. Okay, back to you.
Okay, thank you. Yes, correct. As an MVP, we can build it and we can always perfect it later. Sorry, wrong button. Okay, now a little refresher to Arduino for you whom already know, and introduction for those who have not experienced Arduino yet. is a small programmable computer that has physical input and output pins for connection to sensors and actuators. It has 13 digital, 13 from 0 to 13, that means 14 digital input and output. It's called GPIO because it's general purpose. So you can either make it as an input or as an output. Over here, we have from 0 to 13, but we usually leave the 0 and 1 alone because this is for serial communications that we can discuss next time, maybe in different video. So usually we use either 2, 3, 4, up to 13. There's a special pin over here, pin number 13, which is also wired to an internal LED. So there's an LED that will lit up if pin 13 is turned on, or if turn off if pin 13 is turned off. So it's wired, the LED here. And we use the logic like this. On means high voltage or 5 volt. So if you apply 5 volt here, it is 1. If you apply 0 volt here, it is low or 0, logic 0. Down here, there are pins that commonly used for us to draw an output. Like in this case, we are going to draw the power from the Arduino board itself to power the motor. Yeah, the motor needs power, so it will be drawn from here. But if you want to use a bigger motor, it is advisable to use external power. Don't draw from the Arduino board. It may damage the board, and it may not work anyway. Okay. So again, we are using this positive logic where if you have a 5 volt on the pin, it's considered as high level, and the logic is considered as true. It represents the binary number of 1, and the status is on. Okay, on the other way, if you put 0 volt, we consider it is a low level, and the logic is false, represents the binary 0, and the status is off. There are some negative logic that applies that I will give you an example later on. That if it's true, it is 0. If it's false, it is 1. It might be confusing, but it comes handy sometimes. So just bear in mind how the logic works. And I will give you an example later. Okay. This is the circuit. I will explain. First, just take a look at the right top over here. There is an Arduino board over here. There's pin 3 that is connected to the servo motor. The servo motor itself has 3 wires that you have to connect to 5 volt and connect to the ground. Okay. Yeah, these are the power. If you use a bigger servo motor, you shouldn't connect to Arduino. This one goes to another power source, let's say another battery or another power supply. The ground also to another power supply, but you have to connect the ground all together. The Arduino ground and the external power supply ground has to be connected. Otherwise, it won't work. Okay. So the pin 3 will be used to control the servo. Now, the pin 7 will be used to sense the status of this push button. This is the symbol of push button, and this is normally open. Normally open means if you don't do anything, it is open. The circuit is open. Okay. If you press, this switch will be closed. Hence, you will see if this is closed, a 5 volt signal will enter pin 7. And from the previous slide, we remember 5 volt is logic 1. Okay, so that means this is logic 1 or true. If the push button is released, there's no 5 volt signal, but it will be going to the ground through this 2 kilo ohm resistor. Hence, Arduino will sense is logic 0 or false. So why do we need to put the 2 kilo ohm resistor over here? Because if you press the button and this is connected to the ground, you will have a short circuit between 5 volt to the ground, which is not very good. It may damage the Arduino, it may damage the battery or power supply. So you want to limit the current over here. But is it enough to give a logic 0 to Arduino? Yes, it is. You can use 1 kilo ohm or 2 kilo ohm, even 3 kilo ohm, even 5 kilo ohm, it will still work. Because it's just to stabilize the pin 7. A modern Arduino, however, have some internal mechanism that in some cases, you don't need to have this 2 kilo ohm pull down resistor to the ground. You can just leave it hanging over there, but with the software, you can define that this is pulled down to the ground, and it will always have a logic 0 if the button is not pressed. Okay, how to turn this into actual wiring? The actual wiring is like this. So I use the breadboard. Yeah, you can always implement this differently, but this is the wiring that I use. I use the side connector of the breadboard to deliver the power, the voltage over here. So I use these stripes to deliver positive, these stripes to deliver the ground. Okay, and this is the button over here to represent this push button. Be mindful that the button, maybe I'll just switch to the camera later on, that the button has 4 legs. A and B are the closer one, B and C are the closer one. From B to C are the far distance. So you want to place it this way. Common mistakes when dealing with button is you put it the other way around, like BC on top and AB below. No, it has to be AB on top and DC below. Okay. Anyway, AB and DC is interchangeable. Yeah, it's the same. So the circuit looks like this. When you press, A and B will be connected, D and C will be connected. It's pretty simple, right? It only needs 4 wires over here. Okay. From the Arduino, and you can connect the servo motor like this, the positive, then the ground, and then you have 1 wire going to the pin 3 of the Arduino as the schematic pin 3 over here. Okay, I don't see any questions so far, so let me just go to I got freezes here. This moment, bear with me. My computer freezes. Nikhil, can you still hear me, or am I losing? Yeah. Okay. Yes, that's fine. That's fine. My computer freezes. I'm not sure why. Okay. It's yeah. It's going now. Okay. Anyway, I'm going to show. I'm going to switch back to my camera. Okay, I have a multiple camera. Let me stop my sharing. You just go very slow. Okay. Now you can see me, right? Yeah. Okay, I switched to my desk camera. So this is the implementation in real world. So I use this line over here to deliver positive, the line over here to deliver the ground. Okay, I took it from the 5 volt pin over here and the ground pin over here. And then the button, I'll just go down a little bit. Yeah. The button, I connect it to pin 7 of Arduino over here. The orange cable goes to the button, and the button is pulled down through a 2 kilo ohm resistor over here, going to the ground. Yeah. And this is the servo motor over here. All right. Great. So now I'm going to share back my presentation. Okay. We were here. My PowerPoint is a bit slow. Okay. What you can do now, if you have not done so, you can download Arduino IDE from arduino.cc, and then you can download this sketch. Sorry, go back to this slide. Yeah, you can download the Arduino sketch from my GitHub page, https://judhi/lockbot, and then open this sketch in the Arduino IDE. After you make sure that the wiring all good, you can connect the Arduino board to your computer via USB cable, upload the code to the Arduino board. If you copy paste it properly, or you open the file directly, it should be giving no issue at all. And then you can test the button by pressing the button with code 001011, or 0 for short press and 1 for a long press. Okay, I will go back to the camera view again, so you can see how it works. Okay, this is the wiring, or let me share my desktop. Not sure, it's a little bit slow here. Yeah, the zoom looks like very slow. Okay, can you see? Yeah. All right. Yeah. So when you open the code on Arduino IDE, it will look like this. Okay. This is where I put the secret code. And let me share my whole screen so you can see better. Yeah, now you should be able to see both my circuit as well as the code, right? Okay. Now we are going to test. We are going to test this by checking. Earlier, there's a question, how to check if the thing is going right. Yeah, there is a feedback here. We use a serial monitor, which is only possible to do it if you connect the Arduino to the computer. But later on, we are going to put the Arduino on the door, right? So the computer need not to be connected all the time. But in this case, we have the computer connected to check if our circuit is correct, if our code is correct as well. So we know that the code is 001 0, 1, 1 over here. Yeah. So we have to enter the key accordingly. 0 is short press, so 0, 0, 1, long press, 0, 1, 1. And we see that the servo is moving. Okay. What if we enter wrong code? Let's say 1, 0, 1, 0, 1, 0. See, 1, 0, 1, 0. You see that every time I press the wrong code, it will go back to the first one. It will check against the first one. So I will never be able to open this if I don't enter the correct sequence. Right? Okay. So now let's do it again. 0, 0, 1, 0, 1, 1. Oops, maybe wrong. Okay, because we didn't start from the correct index. So we just try again. 0, 0, 1, 0, 1, 1. This time is correct. So yeah, there's a chance you entered the right code, but it doesn't open because you didn't start from the correct index. But if you repeat it, it should work. And this will confuse the brute forcer, right? will confuse the intruder. By the way, if you have difficulties remembering the code, this is why I choose 001011. It rhymes with this. Happy birthday to you. It's a happy birthday to you. It's easy to remember. You can always use your own song or your own rhyme, right, to represent 0 or 1. Okay, one more. What if I just keep on pressing 1, 1, 1? I press randomly like this. I press random. First of all, they wouldn't know that it has to be long or short press, right? So they keep on trying, doing things. Okay, it won't work until you enter. Happy birthday to you. Yeah, it works. Okay. Now we know that it works, right? But again, how the code works. All right, I'm going to share the presentation again because I have prepared for you the explanation of the code. Okay. The first line, I just took out all those comments. So it starts from 10. Include servo. Servo.h is a library of Arduino that allows us to use a servo motor without too many lines of programming, because everything is already taken care of in the library. So we can just use fewer lines in our code. Servo 1 is to define that, okay, we have a servo called servo 1 is an object definition over here. And then line 13 is where we enter the secret code. My secret code in this case is 6-digit. You must make sure that if it's 6, then it has 6-digit over here. If you want to put 10, you have to put 10 over here, right? It has something to do with how a C programming language works, so you have to be consistent here. If you want to use 3, it's also possible. Just put 3, you put 3, but then it will be too easy to guess. You can have a very long one, but unless you have a song that you remember to represent those 1 and 0, it's probably difficult. Okay. Then we have a variable C, which we will use to store the input later on. Okay. And then the index, we start from 0. Index, we are going to use to indicate which position of the code that is currently being compared. Button pin 7, remember, we connect the button to pin number 7 of Arduino. And then in this case, we use a LED pin number 13. Remember just now that we have the pin number 13 is wired to the internal LED. Okay. The servo pin is connected to pin number 3. If you want to use different pin for the servo, just make sure that you are connecting to a pin with how do you call that? A tilde, a sign that looks like a worm in front of it, indicating that it's an analog pin. Yeah. And then we have several other variables, a Boolean type variable called B. We use Boolean because it's just true or false. And then we have a B old to store what is the previous state of B. And then there's also another Boolean to store a change state indicator. And we have a variable to store the time start and the duration of it. This will be used to determine whether is it a long press or is it a short press of the button. Okay. In the setup, we attach servo pin, which is pin number 7, as pin number 3 into the servo 1, and then LED pin output, pin number 13, and then button pin, which is pin number 7 as the input. And we begin outputting something to the serial port. Okay, so we can see those indicators just now. In real implementation, after this is done, after you successfully enter this, you don't have to do that, right? You don't have to always watch on the serial monitor. Okay, here is the trick, how we differentiate long press from the short press. In the loop section, first we will read the state of pin number 7 and put it into variable B. So it's a digital read 7. If the button is pressed, B will has a value of 1 or true. And if it's not pressed, it will be 0. And then the next one here on the line 39, I will compare if B and not B old is the same. Like if it's pressed now and if this is not pressed before, remember B old is the previous state of B. So if I press the button and before it was not pressed, then this will be executed. Means it indicates the beginning of button pressed. If you already press it and the loop comes back here, this will not be executed because the button previously is already pressed and is still in the state of pressing. So this won't be executed anymore. This is only executed when the button change state from 0 to 1. Okay. Now, we put here, there is a function called millis. Millis indicates the time taken since the program has started. So it's always unique, depending on what time is it. Yeah. So if it's now, T start, the time now is put into T start. A few milliseconds later, millis will produce different number already. As it says, millis is a millisecond. So we will be able to tell how long the button has been pressed by comparing over here, by comparing this is, well, when the button is released and of the button pressed, we will take again the millis value on that time minus the time when it was started. Hence, we will know the duration, which we will put on the variable d over here. Okay, this is the trick here. Now we know the duration, but we have two states, either 0 or 1, right? In the code, there are 0 or 1 code. So if d is less than 250, in this case is what? Millisecond, means it's about a quarter of second. This will be considered as 0. If it's longer than 250 millisecond, it will be considered as 1. Here is the trick. Yeah. Of course, if you want to change this, it's possible. You want to change this to 500, that means if you press it 300 millisecond, it will still be considered as 0. If you press it longer than half second, it will be considered as 1. You can put it as 1000. So short press, anything that is below 1000 millisecond or anything that below 1 second is still considered as a short press, and anything that is beyond 1 second is as a long press. But to keep things easy, because sometimes I get impatient, I just set it as 200 millisecond or a quarter of a second. Okay, then the line 52 here is to print the C, so that's why you can see just now, when I press short, it will be given a feedback to me that I was pressing 0. If I press it long, it will give 1. Okay. And this is the comparison where we do a state machine checking over here. When it just begins, it will check with the first index in the C, index 0, right? In the secret code, sorry. In the secret code that we have, remember up here on the line 13, we have my secret code as 001011. Index 0 is 0, index 1 is 1, index 2 is 2, index 3 is 0, index 4 is 1, index 5 is 1 again. And this index will keep going if you keep entering the right code. If you enter the wrong code, you will go back to index 0. So it will be compared back to this key if you enter it wrongly. So in other words, you have to start all over again. Okay. Now, if index of size of my secret codes divided by 2, why is divided by 2 here? Because size of my secret code is the length of this key times 2, because it's a bytes. So if I have 6, it will be 12. So to make it back to 6, I have to divide it by 2. So you can just imagine the whole thing here is, if I enter all the key correctly, yeah, then it's success. It's a success. If I enter, in this case, 6 times correct key, like this, the index will advance until it reach all 6. Then it is success. Do something over here. We will see what it will do. And start over again. Don't forget to reset this, because if you don't reset this, the index will be 7, 8, 9, which is not valid here because you have only this many, right? So you have to reset again back to 0. Okay. These are some statements just to give you feedback. Zero print code, like what you saw on the screen just now. Yeah. And there's some delay over here to make sure that there's no bouncing of the button, because sometimes when you press the button, it bounces and it gives you a false data. of course, maybe you press it once, but the button took it as you press it twice because it bounces in few milliseconds. So I give a delay over here for 20 milliseconds to make sure that the button, if it's bounced, it doesn't give any problem. All right. So I don't see any questions so far. I'll just go ahead. So let's take a look what success means over here. Yeah. I put the success here on different function, different procedure to make it easier for us to see. Yeah, because otherwise, if I put everything inside this block, it will be too cluttered. The code will not be very nice to read. So by separating them, we can always modify this later on. Okay. First, it will print serial print line success. That's why you saw the word success when I entered all the correct codes. And the LED will turn on. And the servo will turn to 0 degree. Wait for 2 seconds. And then turn off the LED. And then turn back the servo motor to 90 degree. Means it's back to the lock position. Okay. And then wait for 1 second and then return. Just to make sure that the servo has returned to the correct position before it returns to the main program. All right. If you want to adjust the code, here are some pointers for you. Oops. Look for line number 13 if you want to, again, enter your own code over here. And the servo, you can adjust this. Why? Because, well, sometimes after you make a lock, it may not be giving the correct rotation. Maybe if I put 0 over here, the rotation is not enough to open the gate or open the lock. Maybe it's halfway, so you have to give different values over here. Maybe it's a 0 over here, keep it, and here you put it 180. Yeah. I will switch again to my camera so you can see again how it works. Yeah. Happy birthday to you. You see how it turns, right? So sometimes this turning is not enough to open the gate. So you may want to turn it further or you want to go back further. Okay. That is where you have to adjust the code. You can build something like this. My assembly colleague, Amar, has built this. In the assembly, it's a 3D printed latch. Yeah, you see this. This is the servo motor. It's much bigger than mine. It's stronger. And there's a mechanism over here. This is the pinion gear, and this is the rack. So the servo will turn the pinion gear, and the rack will move. It will move linearly, and it will like lock or unlock the door over here. Okay, there are some other 3D printing design which I will include the description later. You can try it yourself. Okay. Now I'll go back to my presentation. Yeah. Now, to make it more interesting, when you use a button, you will hear the click sometimes. You hear that, right? Sometimes you don't want that to happen because, somebody could just listen to the click and try to imitate the sequence of the push button. Okay, let's make it more interesting. How? We change the button, to a sensor. In this case, it's an infrared obstacle sensor. So infrared obstacle sensor is using negative logic. Remember, I discussed about this before, yeah? So the output here, the output of this sensor will be 0 if there is an obstacle, and will be 1 if there's no obstacle. So we have to keep this in mind. Either you want to change the code or you want to change the behavior of or how you enter the code. All right. I will just demonstrate to you. Let me share my whole screen so you can see. Okay, you can see this, and you can also see my video. Yeah, right now I have button, right? If I press it, you can hear the click. It's a clicking sound. Now I'm going to change the button to an infrared obstacle sensor like this. If there's any obstacle in front of it, the output will be 0. If there's no obstacle, the output will be 1. Okay, so now I'm going to connect this. It's a good practice to use like a dark color for ground and light color for positive or VCC. So I put it like this. I already have 2 lines here representing the ground and that. And this will be the output. Since we are not going to use the button, I can take out the input wire that is going to the button. I'll just put it somewhere else, far from there, maybe over here. Yeah. And then I will join it with the output of the infrared. Okay. Maybe I can't see that in person, but my camera can see that this is emitting light. So the way it works is that there's a light here. And if you put something in front of it, it will reflect something, and there's an LED there. See, maybe it's a bit too sensitive. Yeah. So you see, there's an LED over here. If there's an obstacle, it will turn on. But again, on is 1. On is 0. So I have to change the logic. How to change the logic? Well, just change the behavior of how you turn it on. Because this will be 0. So you don't see the, can you see the, okay. So now I just cover the whole thing. So this will be the beginning of my code as if the switch is open. I will do the same sequence. Happy birthday. Oops, wrong. So I have to repeat it again. Okay. Happy birthday to you. Wrong. That means, okay, I have to close it again. See? It's open. Let's do it one more time. Happy birthday to you. Okay, a bit wrong. So let me use something that is more reflective. Right? My card over here. Okay. 0, 0, 1, 0, 1, 1. Okay. Oh, I'm out of camera. Okay, I'll do it one more time. Okay. 0, 0, 1, 0. Oops, too long. 1, 1. It won't open. Okay. One more time. 0, 0, 1, 0, 1, 1. I know why. Because I'm pointing to the sun. it always detects there's something over there. So I have to trim this down, trim the sensitivity down, so it won't detect that far. Okay. Okay, now looks better. All right. Yeah, as you may realize, I purposely make this mistake so we can learn, all right, that infrared will take the sun as an infrared as well. So as if this is see the reflection while it is actually not. Okay, so 0, 0, 1, 0, 1, 1. Okay, oops, doesn't work. Again, 0, 0, 1, 0, 1, 1. Something is wrong, maybe my wiring. Some wires not connected. Okay, in this kind of situation, it's always good to, let's see if we go back to the original wiring and check if our circuit is still working, right? 0, 0, 1, 0, 1, 1. Still not working, so yeah. Okay, luckily we have this serial monitor, remember? So here, every time we enter the code, we can see what is the actual code. All right. Now we try again with this. That's why we have a serial monitor to check if everything is working properly. Okay. So 0, 0. Okay, it was too long. So the second code was too long. I have to be quicker than that. 0, 0, 1, 1, 0. It's wrong. It's supposed to be 0, 0. Oops. It's a bit difficult, too fast. 0, 0, 1, 0, 1, 1. Success. One more time. I hope you can. Okay, okay, okay. Now it's showing, yeah? We are good. Okay. My webcam, oh, sorry. It's hidden there. Okay. Okay, so again, we have the first one, 0, 0, 1, 0. Oops, the third one is wrong. So we go back to the state 0, 0, 0. It's not very reliable. Maybe I have to change the code a little bit to allow longer input to be considered as 0. So remember, we have to change it over here. So we allow now half second instead of a quarter of second to be considered as 0. I hope this will make it more reliable with this kind of sensor. Okay, uploading, 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 done uploading. Okay, we go back here and turn on the camera. Now, just start from, okay, 0, 0, 1, 0, 1, 1. Success. So you see here that I just changed the code to make it more reliable so that I can open and close this sensor up to half second to represent 0 and more than half second to represent 1. Let's do it again. 0, 0, 1, 0, 1, 1. Success. Okay. All right. Go back to the presentation now. Unless you have any question, as usual, you can always type it there. Okay. You can also use a touch sensor. I don't have it right now, but it goes with the same principle. You can touch it. You can touch short, touch long. It will give the same effect as button or as the infrared over here. So I give this example over here. You can always replay this video later if you decided to get yourself a touch sensor. And imagine if the door is not that thick, or maybe is a box, it's a small box. You can hide the touch sensor under the box. It will still register your finger or your touches. So you don't see any button. You don't see any button. You don't see any lights. You see nothing. But actually, there's a touch sensor that you can touch on that area, and that will serve as an input. So just touch it. Yeah. Okay. So you touch shortly or quickly to give a logic 0, and touch longer to give a logic 1.
Quick question
How
for
long
you,
you-
Professor.
There is
Quick
a
question
question?
for you,
Yeah.
Judhi.
Yeah.
How difficult would it be to maybe connect this to a fingerprint sensor? Because I know there are fingerprint sensors for the Arduino.
Mhm.
And would it also be possible to put in maybe some analytics? Like you could communicate maybe with the cloud or something and just keep a track of.
Yeah. Okay. Very good. That's very advanced and forward thinking. Yes. Usually the fingerprint sensor is a module by itself that give the input to the Arduino based on what it senses, which is the fingerprint. So the problem here is that you have to register each of the finger that you want to use
Right.
to open the door. So you cannot share the code. You cannot share your finger with anyone else.
I'm just thinking
Which is
about
good
version
for analytics
3.0
because
maybe.
each individual will have their own, right? So you can analyze. It's good for analytics. Your idea is to analyze who comes at what time. Yes, it is good. But the goal of this is just a simple lock that you can use inexpensive sensor, inexpensive stuff, including just a button. So yeah, there's no analytics because if you want your friend to be able to open, you have to share this code to them.
Right.
Of course, with some clever programming, you can have two different codes and make the program to check against these two codes. If any of the code matches, then it will open anyway. So you can have one code for yourself and the other code for your friend. And then you can write additional line to upload like indicator like which code is doing the opening at that time. Yeah, hence you can do a simple analytic. But things will get complicated if you have multiple people in the house and you want to give the code individually to them. So this will
I'm sure there are
become
many
impractical.
things we can think of, even like maybe like a camera that, because there's so many different things available with the Arduino. So I guess the basic setup what you've shown here is always like sensor. For the basic robotic setup is sensor, Arduino, and an actuator. But you could,
Exactly.
I mean, and with expansion boards, you could probably even have more actuators. You could do multiple things. You could have cameras. You could take a picture of the person who's opening the door. There's so many things you can do, but this is the bedrock on which you form all that. So, yeah,
Yes.
it's good if people keep thinking about it. That's this is like you said, robotics for all. This is not.
Yeah.
This is all what we're talking about is not expensive hardware, and it's not sophisticated in the sense that
Yeah.
you need an expert to use it. So I think it's fantastic. Okay, I'll just
Yeah.
yeah,
You're right, Nikhil. So sometimes the key is not the hardware. Most of the time, the key is the software. So probably some of us never imagine, oh, okay, so one button can do so many stuff. Yeah. This was not really invented by Apple, but it was popularized by Apple with only with a mouse that has only one button. At that time, the competitor of Apple has mouse with 3 buttons, and Apple came up with a mouse with 1 button. It's simple hardware, but they trick it with the software. So one button can do multiple stuff depending on first is how many times you click the button or how long you click the button. So there's a long press, short press, which the same concept is used until now with different input. For example, on your screen, when you interact with your phone, there is a quick touch, there's a long press, there's a double tap, so there's a triple tap sometimes. Okay, tap and drag. So this kind of user interface is become commonly used because it's intuitive, it's easy, and it saves a lot of money because you don't need a keypad for this, right? You can have just one button. Okay, so that actually conclude my presentation and my sharing of workshop today. If you have any question, let me just stop sharing my presentation and go back to the to the camera over here. Yeah, if you want to see the hardware one more time, okay, that's the infrared sensor. Yeah. Okay, so thank you so much for being with us today. I hope what I just shared is useful for you, and you can equip your home with a smart lock like this and have fun with it. Or annoy your friend that you can unlock something, but he cannot unlock something. Yes, learning should be fun, right? So you have to make fun of this. Yeah.
Okay, I'm back on screen with you, Professor. We've definitely had, I think we've just gone over the very basics, but we can definitely do a lot more. I mean, Arduino, as we've seen at the assembly, over the last few years, we've done so many different things with it. It's interesting though, I'm sure when people think about robotics, they think about, okay, you have your moving arms and all that, but this is the basic building block, isn't it? This is
that's true. Even human doesn't have to have arm and legs. I have seen some human being don't have arm and legs, but they're still human beings. So similarly to robot, doesn't have arm and legs.
I think the basic thing is always sensors and actuators, right? I mean, if you have a sensor and an actuator and logic that is being executed, that's a robot. So it's so many things. I mean, it's a few steps up to get to your Peppers or the other kinds of robots. And I've seen the ones you even have in the RoboTech lab. You have the very sophisticated robotic arms. Those are just actuators moving in different things, and it's the logic that really decides it.
Yeah, those big robot is the actuator, and the input we can use anything. Even we can use button like this. In some experiment, we use the brainwave sensor that we can connect it. You think of something and the robot moves.
Yeah, now the Neuralink thing is they're trying to even make it even more advanced, right? The neural interface with electrodes and whatnot. So who knows? I mean, that's what the future is like. We're going to see a lot more of robotics, and it's really exciting. Thank you so much, Professor. I have to get out of this habit. I'm sorry. Thank you so much, Judhi. It's amazing, what the work you're doing, and of course how you've been able to share that with our community. We are going to come back next week with another workshop. We will say bye to you now, but next week we will have another workshop. We're trying to keep the Corona theme going. We're trying to see things that we can use electronics. So we might show people how to build a sanitizer that you can automatically dispense, which is another robot. Thank you again. I've shared the GitHub links, and any questions you have, please do keep it going with us. And after that, do tune back next week as well. And if you have any questions for Judhi, send them to us. We will make sure that we can share it across. We will definitely be back with Judhi again. We like to keep that connection fresh. Every few months we do make sure we have one workshop. Thank you for your time.
Yeah, it's really fun. It's really a good relationship we have with Assembly for the past 4 years, I think. Right.
Right from the start. So it's as old as the assembly itself. So yeah, we will definitely see you again soon. Thank you, everyone, and please do keep your comments going. That concludes our workshop and our stream. Bye-bye.